Welcome to today's lesson. I'm Siamasaka Kendins. And so today I'm going to take you through a lesson in chemistry. And so we go straight to the lesson for today. Well, today, as I've indicated, we are going to look at percentage composition by mass. We will definitely determine the percentage composition of an element in a compound. And so we expect that we are going to have a compound, and in there are several elements. And so we'll determine the percentage which is actually contained in that actually compound. And so we'll go straight into a lesson. Here is a very basic question that we'll go through. What is the percentage of oxygen by mass in hydrated magnesium sulfate? And so we want to see actually the composition of oxygen. We note that here we have actually 5 atoms of oxygen. We have oxygen in magnesium sulfate, and also in water we have actually 7 atoms. And so the first thing that we need to do is to find the relative molecular mass of this compound. And so we say the relative molecular mass of hydrated magnesium sulfate would be equal to the subscript for magnesium is actually 1 multiplied by actually 24, which is actually relative atomic mass for actually magnesium, plus subscript for sulfur is actually also 1 multiplied by the relative atomic mass of sulfur, plus the subscript for oxygen is actually 4 multiplied by the relative atomic mass for oxygen, plus the relative molecular mass, because this is a molecule, water here is actually a molecule of water. So what we get here is actually 1 multiplied by 24, which is the relative atomic mass for magnesium, plus 1 multiplied by 32, the relative atomic mass for sulfur, plus 4 multiplied by 16, which is the relative atomic mass for oxygen, plus actually 7 multiplied by the molecular mass, relative molecular mass for actually water, which is actually 18, which is for oxygen 16 plus 2 for hydrogen, which is actually 18. So we have actually 24 plus 82 plus 64 plus 126. And so it gives us actually 246 as the relative molecular mass for actually magnesium, hydrated magnesium sulfate. Okay, so now that we have found the relative molecular mass for hydrated magnesium sulfate, then we can actually now get the percentage of oxygen in this, and we know that the percentage of oxygen actually in magnesium sulfate is actually 64. So percentage composition of oxygen in hydrated magnesium sulfate is equal to actually, we said we have 64 plus actually for water, oxygen actually, which is 7 times 16, which is actually 16 times 7, which is 2 here, and plus 4, which is 1, so which is actually 112 divided by what we found as the relative molecular mass, which is 246, and then the whole of this we multiply by actually 100, which gives us actually 176 divided by 246 multiplied by 100, which gives us actually 71.5%. So the whole of this compound actually contains 71.5% of oxygen. So this is basically what we do. Then we do the other question. The other question is actually also requiring us to find to identify actually the element. So we are told that the compound below was analyzed and found to contain 38.8 chlorine by mass. Find the relative atomic mass of element Y and identify the element. So we have actually this compound, which is chlorine, and then Y. Okay, and so this one we need to, first of all, actually we need to find the relative molecular mass for this compound. And so we note that actually chlorine divided by relative atomic mass for this compound. Okay, multiplied by 100, it gives actually 38.8%. So we know that actually the relative atomic mass is 35.5 multiplied by 2, which is actually 71. And this one actually is also 71 plus 7 multiplied by y, which is multiplied by 100, which is equal to 88.8. And so what we have here is actually, we can actually cross multiply this. So what we're going to have is 71 multiplied by 100 is equal to 88.8 multiplied by 71 plus 7 1. So this gives us actually 71 is equal to actually 88.8 multiplied by 71.71. So then what we can get is actually that we can say 71 divided by 38.8 is equal to 71 plus 7y. And this gives us actually 183 is equal to 71 plus 7y. And so we have 183 minus 71, which is equal to 7y. So we have 112 is equal to 7y. Therefore, y will be equal to 112 divided by 7, which is equal to actually 16. So we have known that actually our y is actually 16. So we have now our compound, which is 2, and the element actually with the relative atomic mass of 16 is actually oxygen. Okay, so oxygen is the one with the relative atomic mass of actually 16 or 16. Okay, and so we have identified the element, and so we go to the last equation. If 100 of hydrated magnesium sulfate crystals were heated and all the water was driven off as steam to leave only magnesium sulfate, what mass of steam was driven off? And number 2 is that what mass of magnesium sulfate would remain? And so we need to find the relative atomic mass of actually magnesium, hydrated magnesium sulfate. So magnesium relative atomic mass of magnesium sulfate, which is hydrated, should be equal to 1 multiplied by actually relative atomic mass for magnesium plus 1 multiplied by the relative atomic mass for sulfur plus 4 multiplied by the relative atomic mass for oxygen plus 7 multiplied by the molecular mass for water, since water is actually a molecule. So we can say it's 1 multiplied by the relative atomic mass for magnesium, which is 24, plus 1 relative atomic mass for sulfur, which is 32, plus 4 multiplied by 16, relative atomic mass for oxygen, plus 7 multiplied by 18, the relative molecular mass for water. This gives us actually 24 plus 32 plus 64 plus actually 126 plus 126, which gives us actually 246. 246 as the relative molecular mass for magnesium sulfate, which is actually hydrated. And so now we need to find, according to the equation, they want us what mass of steam. So we can look at the amount of actually steam. So we have to get for steam, which is actually 126. So so they want us to find what mass of steam was driven off. Okay, so the mass which was actually driven off can be found by dividing 126, which is actually the relative molecular mass for water, divided by 246, which is the relative molecular mass for hydrated magnesium sulfate, multiplied by 100, which actually would give us 51.2 grams. Or that one, because they said 100 grams actually contains that. Okay, and so number 2, they want us to find actually what mass of magnesium sulfate would remain. So here, what mass would remain for magnesium sulfate, that is without water. And so we know that actually 100 grams gave us actually the relative molecular mass for magnesium sulfate, which is hydrated. Its mass, so 100 grams, gives us actually 246. And so what of X, what would be the relative molecular mass for actually magnesium sulfate alone when all the water has been driven off. And so we're going to have 100 is equal to 246. And this gives us actually 120 will be equal to X. So we can find now the mass which will be there for actually magnesium sulfate without water, which would be basically 100 multiplied by 120 divided by actually 246, which gives us actually 48.7 grams. And so today I thought we would look at the percentage composition calculations. And so I feel we have learned something from here. And so continue subscribing to my YouTube so that you can get more of this lesson. Thank you.